All right, so now that you've actually written your first MapReduce program, it's time to understand what actually went on there. So let's take a look at some similar examples using the same data set from MovieLens and kind of walk through how MapReduce works, what's a mapper, what's a reducer, and how does it all fit together. All right, so before we start diving into code, let's get some fundamental concepts about MapReduce under our belts. This is really important before you can understand what the code does. We need to understand what MapReduce does at a high level, what a mapper does, what a reducer does, and what happens in between, and how you can use that to do big data analysis and spread that out over a cluster. So the first thing a MapReduce job does is run a mapper. It does mapping. And all the mapper does is take your raw source data and parse it and extract the information you care about into key value pairs. So what does that mean? So let's take some examples. So let's say we have the MovieLens data set, which is just a bunch of movie ratings broken up by user ID. So each row of that data set is a user that rated some movie, some given rating. And we want to analyze that data in some way. So let's say that we want to count up the number of ratings each movie has. Now in that case, the key would be the movie IDs, and the values would be the ratings for that movie. So there's sort of a one-to-many relationship there. If we want the number of ratings per movie, the key is the one unique identifier we care about, the movies, and the values will be each rating for that movie. So let's take another example. Let's say that we wanted to get the average rating per user. In that case, the key is the user, because we care about user behavior, what the user is doing, and the values will be each rating for that user that we want to add up an average. Or in the example that we're going to do throughout this particular lesson, let's say we want to count up the number of movies each user watched. In that case, the key is the user, because what we care about is something the user is doing, and the values will be each movie that each user watched that we want to count up later on. So that's what the mapper does at a high level. It just parses your source data and extracts key value pairs out of it for the information that you care about in your analysis. So let's make it a little bit more concrete. Let's look at some real data here. So the u.data file in the MovieLens dataset represents movie ratings data, like we said, and it will look something like this if you were to open it up in WordPad or a text editor of some sort. So each row represents a user ID, and that's just to keep things anonymous and more compact, followed by a movie ID. Again, that's just a more compact way of representing what a movie is instead of its full name, followed by the rating that user gave that movie, and a timestamp. That's just a big number that indicates when that rating was made. So each row is just this user watched this movie, gave it this rating at this time. Now in the example that we talked about, what we're going to do is try to figure out how many movies each user watched. So what do we actually care about in this data set? Well, in this case, the key is going to be the user ID, like we said, and the values will be each movie that user watched. So our key will be the user ID, the value will be the movie ID. What about the rating and the timestamp? Well, we don't actually care about that information. All I'm doing is counting up the number of movies each user watched. So what they rated each movie and when they rated it, that's actually irrelevant to my problem. So I'm just going to throw that data away as part of my mapper. My mapper is going to take each row one at a time. It will be called for each row of my data. And the mapper function's job is to extract the key and value that I care about. So my mapper for each row of data is going to extract a user ID as the key and a movie ID as the value. So let's take a real example here. So this is what your u.data file might look like if you were to open up in a text editor or WordPad or Notepad or something. What it looks like is a bunch of rows where each line represents a user ID, the movie ID that user watched, the rating the user gave that movie, and the time that rating happened. So our mapper will get called for every line of our input data, and our mapper's job is just to extract key value pairs. Again, we're trying to figure out the number of movies each user watched, so our key will be the user ID, and our value will be the movie ID. So our mapper function will take in each line. Let's say that the first line's coming in, and it will split that line up into individual fields, and it will output as a key the user ID of 196 for the first row and the value 242 for the first row. Again, user ID 196, watched movie 242 is what that's telling us. And for the problem we're trying to solve, how many movies did each user watch, we don't actually care what they rated the movie, and we don't care when they rated the movie. That information's irrelevant. So our mapper will just throw that information away. We don't need it. It's just wasting space as far as we're concerned for the problem we're trying to solve. So second line comes in. Again, we'll just extract the user ID 186 and the movie ID 302 as the key value pair, and output a key value pair of 186 to 302 to MapReduce. Third line comes in. We extract again user ID 196, watch movie 377. And this is the second time we've seen user ID 196, and that's okay. You know, duplicate keys are okay. What MapReduce does for you is combine all that information together for each user automatically, and that's where the magic happens. But for now, all you need to understand is that your mapper function is responsible for parsing each input data row and extracting a key value pair that you care about for your analysis. So again, the role of the mapper is to extract and organize what you care about in your source data. In this case, the output from our source data after the mapping phase is complete is simply a bunch of key value pairs where each key is a user ID and each value is a movie ID. So after the mapper runs, MapReduce will know that user ID 186 watched movie 242, 186 watched 302, 196 came back again and watched movie 377, user 244 watched movie 51, and so on and so forth. Now these are very important concepts to get, so if you're still not clear on how a mapper works and what a mapper does, please hit pause, rewind, rewatch what you need to rewatch. Fundamental stuff here that the rest of the course is going to depend on. Now what happens next is kind of magic. So you don't have to write any code for this to happen. This is just what MapReduce does for a living. It will all happen for you magically under the hood. It will take that list of key value pairs that your mapper output, and it will sort them all by the keys and then group together all of the values seen for that key automatically. So let's look at an example here. In our data, the lowest user ID we have is 166, so that gets sorted to the front. And it turns out user 166 only showed up once in our key value pair list with a movie of 346 that user watched. So in this case, nothing really happens. 166 gets sorted to the front and is still associated only with movie 346. But look at user 186. So 186 is next in our sorted list of users, but 186 actually watched 3 different movies in our data: movie 302, movie 274, and movie 265. So the MapReduce framework will group all of those together for us and produce that user ID 186 watched movies 302, 274, and 265 as a list of values all associated with that key of 186. User 196 comes up next in our sorted list of keys, and that user showed up twice in our data watching movies 242 and 377. So again, it's organizing keys to a list of values associated with that key. Finally, user ID 241 only watched one movie, 51. And this information is what gets fed into our reducer, which is the next step of MapReduce. So for every key, our reducer will get called along with a list of every value that key had associated with it. So let's take a look at that. So again, your reducer's role is to produce the final output of your MapReduce job given this list of keys and all of the values associated with each key. In our case, it's going to be a list of user IDs followed by a list of each movie that each user ID watched. So for each key, each user ID, our reducer will be called once. And let's say the first one that comes in is user ID 166. Since I'm trying to find out the number of movies each user watched, all I'm going to do is count up the number of movies that come in that list of values. So say I have some function that counts up the length of that list. It will output for that first key 166 only watched one movie, 346. Then the reducer gets called again for user ID 186, and we get a list of 3 movies. So our reducer will just count up that list and say, hey, I have 3 movies in that list. And output in the final output, user ID 186 watched 3 movies. And similarly, user 196 comes in with a list of 2 movies. We count up how many items are in that list, and we output 2 for user ID 196. And this is how we've taken a large data set of ratings for movies, and we've used it to count up how many movies each user watched. And the beauty of it is that this can all happen in a very scalable manner. So under the hood, MapReduce and Hadoop are doing the hard work of spreading this work out over multiple computers potentially, or multiple threads or whatnot, and bringing it all together and making sure everything happens in the right order and in the right place. That's where the real scalability comes in. But the key is to think of this problem as a MapReduce problem where you have to think about what key and values do I want to extract from my source data? How do I want to add those up or manipulate those value lists per key to produce the final output of my analysis? Let's put it all together just to have it all in one slide and kind of make it all fit together here. So again, starting with our raw input here, we have user ID, movie ID, rating, timestamp is the source data from the u.data file. For each line of that input data, our mapper will get called and our mapper will extract a key value pair. In our case, the keys will be the user IDs and the values will be the movie IDs. So for each row, we produce one key value pair saying that this user watched this movie, this user watched this movie, this user came back again and watched that movie, so on and so forth. Then in the magical phase of MapReduce, all those keys are sorted and then grouped where all the values are associated with their key. So each unique key shows up and we get a list of all the values associated with that key. So we know that user ID 166 watched movie 346, user ID 186 watched these 3 movies, user 196 watched these 2 movies, and user 244 watched this 1 movie. And that's what gets produced as input to our reducer function. And our reducer function that we write will be called once for each key, each unique key, and received a list of all the values associated with that key. So our reducer will be called once for every user and receive a list of all the movies that user watched. And in our example, all our reducer is going to do is count up the number of movies in that list and make that the final output. So our reducer says user 196 only watched 1 movie, user 186 watched 3 movies, 196 watched 2 movies, and 244 watched 1 movie. And that, at a high conceptual level, is how MapReduce works. You need to think about how to extract keys and values that you care about from your source data, how the power of associating all of those values with each unique key will help you write a reducer function that produces the final output that you care about. So we had a data set of movie ratings for each user. We want to count up how many movies each user watched, so we know our keys needs to be the user ID, our values would be the movie ID, because we know that MapReduce will under the hood combine together automatically all the movies that each user watched, and then we can count them up to produce the output that we want. So apart from thinking through how it works, the things that we need to do as programmers, as developers, is write that mapper function that actually parses the data and extracts the key value pairs we care about, and write the reducer function that actually analyzes each list of values associated with each key. And that code, as you can imagine, is actually fairly simple. That's the easy part of this whole problem. The hard part is framing problems as MapReduce problems, and that's what this course is all about. So I want to make sure that you understand this lesson very deeply. If this doesn't make sense, please go back and watch it again, because getting a firm grasp of the fundamentals of how MapReduce works really is fundamental to the rest of this course. So make sure you got it. Don't be afraid to go back and rewatch this if you have to. And with that, let's move on. Great, you should have the concepts now of how MapReduce works and what a mapper does, what a reducer does, and what MapReduce is doing in between to sort and group data for you automatically. So next, let's go back and take a look at that code that you originally wrote in the first exercise and walk through that code and see what it actually did.